Welcome to Sanjay Goda Ayat Medical Academy. My name is Uday Shankar. Today I am going to discuss the graphs in the kinematics. See, first of all, displacement time graph. Suppose observer is here, body is rest. At this point, body is at rest. This is the observer, is observing. Initially, he has some displacement, yes. At t is equal to 0, if body is at rest, at t is equal to 0, it is at this distance only. At t equal to 1 second, here only. At t equal to 2 seconds, this displacement is same. At t equal to 3 seconds, this displacement is same. At t equal to 4 seconds, this displacement is same. Then displacement time graph, you will get a straight line parallel to the time axis. Okay? Now, body is moving away from point of observation. Body is moving in this way with uniform, or body is moving with positive uniform velocity. Positive uniform velocity means if body is moving away from the observer, positive velocity. Body is moving towards the observer, negative velocity. So, positive uniform velocity. Body is moving away from the observer. Displacement is increasing. Uniform. Uniform means at t equal to 0, suppose it is started here, displacement is 0. At t equal to 1 second, it travels 1 meter for example. At t equal to 2 seconds, it travels 2 meters. T equal to 3 seconds, it travels 3 meters. So, displacement time graph is a straight line. Suppose this is meaning that body is started from point of observation. It is positive velocity, body is moving away. Positive velocity, displacement is positive. Body is moving away. It is started from this point of observation. But suppose already body has some displacement at t equal to 0, it has some displacement S0. For example, it is at a displacement S0. From that point, it is increasing uniformly. At t equal to 1 second, it is here. At t equal to 2 seconds, it is here. At t equal to 3 seconds, it is here. Then, displacement positive means velocity is positive. If you are getting a straight line means this is uniformly increasing displacement with time. So, that is uniform velocity. Uniform velocity. You know that displacement for uniform velocity is equal to V into T because A 0. S is equal to UT plus half AT square. A 0. So, S is equal to V into T. So, S by T is V. That means, if you take slope of this graph, this is the displacement, this is the time. So, y2 minus y1 is displacement. T2 minus x2 minus x1 is T2 minus T1. This is the velocity. That means, the slope of displacement time graph gives the velocity. The slope is positive. Then velocity is positive. So, what we have to know? The slope of displacement time graph gives velocity. Velocity. If body is moving with negative uniform velocity, negative means this is the point of observation. Body started here. It is coming towards at t equal to 0. It is here. At displacement, yes. At t equal to 1, it comes here. Displacement is decreasing. It is coming towards the point of observation. So, body is moving with negative uniform velocity towards. It is coming means negative uniform velocity. So, if displacement is equal displacements in equal intervals of the time, equal displacements in equal intervals of the time, but displacement is negative, means it is coming towards the point of observation. This is the reference point. Then that graph is in this way. Here, slope. We already know that displacement time graph slope is velocity. Here, theta. Tan theta is obtuse. So, slope is negative. So, velocity is negative. Displacement decreases, so velocity is negative. Here also we can say that tan theta more than 90, tan theta is negative, so slope is negative, it gives the negative velocity. In the previous case, it gives the positive velocity. Slope is positive here, it gives the positive velocity. Means it is going away. Here it is coming towards. Suppose body is moving with acceleration and started from the origin. Started from the origin means here point of observation here, body is started here. Body is moving with acceleration, started from the origin. Then at this point, if you draw the graph slope, that slope is, let us take this theta 1. Here this angle is theta 2. Here this angle is theta 3. Slope is increasing, theta is increasing. From point to point, slope is increasing. So, theta 1 is less than theta 2 is less than theta 3. That means slope is increasing means velocity is increasing. Velocity is increasing. So, we can say that when velocity is increasing, body is acceleration. Body started from the origin means point of observation. Suppose body is not started from the origin. Suppose the body is started from some initial displacement. Initial displacement. Then what you can write now? This one. So, body started some initial displacement, that graph, body is moving with acceleration and started at a point at some initial distance from the origin. Origin means point of observation. Suppose body started from the origin, that graph comes in this way. Body is not started from the origin, that graph comes in this way. Body is moving with uniform retardation, started from the origin. Body is moving with uniform retardation. Uniform retardation meaning what? Velocity is gradually decreasing. How we can say that velocity gradually decreasing? Here slope is decreasing. This is theta 1. Here slope is decreasing. This is theta 2. Here slope is decreasing. This is theta 3. Here theta 1 is greater than, theta 2 is greater than, theta 3 is greater. That means here velocity V1 is more, then V2 is more, then V2, then V3. Velocity is gradually decreasing. Gradually decreasing because this is a regular graph, so gradually decreasing. Then it is started from the origin. It has retardation. Retardation. Right. Now, what we can say that here, this is acceleration graph is in this way. Displacement is increasing, so positive velocity. Positive velocity. This is also positive velocity. Displacement is increasing. Displacement is increasing. But positive velocity. Positive velocity is positive. But initial velocity is more. Gradually at this point velocity less. Here velocity very less. That means velocity is positive. But velocity is increasing. Here velocity is positive, but velocity is increasing. So, this is retardation, this is acceleration, but both have positive velocity. Displacement is increasing function means positive velocity. Body is moving with retardation and starting at a point at some initial distance from the origin. This is the origin. Body, that means point of observation is here. Body is moving. It is started from this S0. This is the origin. It has S0. Initially, it has some S0. The t is equal to 0. It is S0. But retardation. Retardation means graph slope is gradually decreasing. So, slope is decreasing means velocity is decreasing. So, retardation. But it is started from some point. So, it has displacement is positive. So, velocity is also positive. Displacement time graph slope is velocity. Displacement time graph slope is velocity. Very, very important point. If displacement is increasing, means body is moving away from the point of observation, velocity is positive. If displacement is decreasing, velocity is negative. For example, we are saying that here, these are graphs. This is graph A, this is B, this is C. Displacement time graphs are in this way. This is straight line means uniform velocity. Displacement time graph is straight line uniform velocity. Then velocity A, VA is equal to tan 31 by root 3. For this velocity VA is equal to tan 31 by root 3. For this velocity VB is tan 45. That is this velocity. VC is tan 60. This is the velocity. They are asking what is the ratio of bodies, velocity of bodies A and B and C. This angle is 45 degrees. This is 15, this is 15, this is 15, this is 30. So, this angle is tan 30, 1 by root 3, this is tan 45, 1, this is 15, but with respect to x-axis, this is 30 plus 15 plus 15, 60, tan 60 is root 3. So, ratio of velocities VA is to VB is to VC is equal to 1 by root 3 is to 1 is to root 3, 1 is to root 3 is to 3. Here, displacement is decreasing. Suppose the body is coming towards the point of observation. Displacement is decreasing. Body is moving towards the point, towards the observer. So, with respect to observer, velocity is negative. Velocity is negative. Okay? Velocity is negative. So, a body is projected vertically up. Displacement time graph is what way? First, body is projected vertically up. Body is going in this direction. So, retardation graph is in this way. Thereafter, it is coming downward, displacement here increasing, positive velocity, बाद में decreasing, displacement decreasing, negative velocity return back. So, this straight line, when your body is projected vertically up, the displacement time graph, this is first retardation. This is, here velocity is positive. Here displacement decreasing means velocity is negative. Towards the point of observation is this one. So, it is going upward, it return back. Velocity is negative. Velocity time graph. Body is rest. This is the point of observation, body is rest. At t equal to 0, body velocity is 0. So, at t equal to 0, body velocity is 0. At t equal to 1 second, body velocity is 0. At t equal to 2 seconds, body velocity is 0. At t equal to 5 seconds, body velocity is 0. Body is rest. So, graph comes in this way. Suppose body is moving with uniform velocity. Suppose for example 5 meters per second. At t equal to 0, 5 meters per second. At t equal to 1 second also 5 meters per second. At t equal to 2 seconds also 5 meters per second. At t equal to 10 seconds also 5 meters per second. So, this is 5 meters per second. So, velocity time graph is in this way. Body rest, velocity time graph is nothing but x-axis. Body has some velocity, it is parallel to the time axis. So, body is moving with uniform positive velocity. This is positive velocity. Positive velocity. So, body is moving with a negative velocity, uniform but a negative velocity. At t equal to 0, at t equal to 1, at t equal to 2, at t equal to 3, at t equal to 4, it is negative velocity. Velocity time graph, slope is acceleration. Velocity time graph, slope. Velocity time graph, slope. Suppose velocity time graph is in this way. Here velocity is v2, here velocity is v1, this time is t1, this time is t2, slope means y2 minus y1, that means v2 minus v1 by x2 minus x1, that is t2 minus t1, that is nothing but acceleration. So, velocity time graph, slope is acceleration. This is acceleration. Body is moving with uniform acceleration. Uniform acceleration means slope should be constant. Uniform acceleration, slope should be constant. But initially it has some velocity. The slope is theta. Then tan theta is equal to velocity time graph, slope is acceleration, tan theta is nothing but acceleration. It has positive velocity. This one also positive velocity, but difference is what? It is 0, started from 0 velocity, gradually velocity is increasing with time. But it is started with some 5 meters per second or 10 meters per second and gradually increasing. But its slope is nothing but acceleration. But slope is constant. At any point, straight line means constant slope. So, slope is constant, meaning acceleration is constant. So, it is going with uniform acceleration but positive velocity. Positive velocity means it is going away from the point of observation. Body is moving with uniform retardation but positive velocity. Positive velocity. Velocity is positive but uniform retardation. So here you will observe that slope at any point slope is this one. Tan theta you will get negative. Tan theta is nothing but acceleration, but negative acceleration is nothing but retardation or deceleration. Retardation or deceleration. Body is moving with uniform retardation but negative velocity. Negative velocity. Velocity is negative. Velocity here gradually decreasing. A negative velocity. Okay. See, body is moving with positive velocity but increasing acceleration. Increasing acceleration. Increasing, you know that velocity time graph slope. Here slope is increasing. Slope is increasing. So body is moving with positive velocity increasing. Increasing acceleration. Body is moving with positive velocity but decreasing acceleration. Acceleration is decreasing, slope is decreasing. So acceleration is decreasing. Slope is nothing but acceleration. Velocity time graph slope is nothing but acceleration. Area under velocity time graph. You see, suppose velocity time graph is any shape. It's in this shape. Suppose I am taking that. At this point, velocity is v, small interval of the time. Small interval of the time. This time dt, velocity is v. What is its area? What is this area? Length is v, width is dt. So area is v dt. Suppose I want to find out the area from this point to this point. This time is t1, this time is t2. So this total area, how to find out this total area in calculus fundamentals? We learned that integration gives the area, total area. To get the total area, you have to get the integration from t1 to t2. But this area is this one. But we know that calculus v is equal to ds by dt. ds is equal to v dt. Total displacement is t1 to t2. So s is equal to integral of v dt t1 to t2. So this value is area. So area gives displacement. Area gives displacement. So if you find out this area, then it gives the displacement. So velocity time graph slope is acceleration. Velocity time graph area under velocity time graph gives displacement. Area under velocity time graph gives displacement. Vertically projected a body, velocity time graph. Vertically projected a body, velocity time graph. Already displacement time graph we draw. That graph is in this way. But velocity time graph, velocity first vertically projected a body, velocity is positive, positive velocity. It reaches highest point, velocity is 0. This is time of ascent. Now after that it returns back negative velocity, and it reaches this point. Means this is time of descent, this is time of ascent, this is time of descent. Total from this one to this one, time of flight. Area under this one, First, this is positive area, this is negative area. Suppose it is started from here. So, return back to same position, plus area and minus area are equal. So, net displacement is equal to 0. But if it is projected from top of a tower, then it will go upward and downward. Then you will get that graph is here. Graph in this way. Here velocity 0. Thereafter velocity comes to this one. Suppose it is plus v. Here you will get the minus v. Thereafter it moves down. Then this area is less than this area. So this area plus, this area minus, total area negative. This area minus this area, suppose this area for example 10, this area minus 30, so minus 20. So this area gives displacement is nothing but height of the tower. This is minus 20, minus 20 gives the height of the tower. Acceleration time graph. Body is at rest. Acceleration 0. At any time, acceleration is 0. So, acceleration time graph comes in this way. Body is moving with uniform velocity. Velocity is constant, means there is no change in the velocity, means acceleration 0. Acceleration 0, that's why acceleration time graph also again this line. Body is moving with uniform acceleration. Uniform acceleration means positive acceleration, but acceleration is constant with time. Body is moving with uniform retardation. Uniform retardation means this graph. Negative acceleration, but acceleration is constant, but negative acceleration. Body is moving with uniformly increasing acceleration. Body is moving with uniformly decreasing acceleration. The area under acceleration time graph, for example, you take this acceleration time graph is in this way, for example, or you can take in this way also. You take, this is acceleration time graph. At this instant, small dt if you consider, this acceleration is a, this area is, height is a, width is dt. So, area of this part is a into dt. But we know that a is equal to dv by dt, rate of change in the velocity. So, dv is equal to a dt. So, 0 to t. Suppose at time 0 is velocity is u, at time t velocity is v, then integration of dv is v. So, velocity u to v, 0 to t. So, integral of a dt gives this area. integral of A, suppose T1 to T2, this area it will give. So, area under acceleration time graph is nothing but here you are getting V, U to V. So, upper limit V minus U is area under the AT graph. Area under the AT graph. Suppose AT graph is given here in this way. So, if you calculate this area gives here change in the velocity. So, area under AT graph gives the change in the velocity. Area under AT graph gives change in the velocity. So, area under VT graph gives displacement, but area under AT graph gives change in the velocity. If body is projected vertically up, acceleration time graph. Acceleration time graph vertically upward minus g. Either body is going upward or downward. Body is going upward and downward. Gravitational force is downward. Acceleration you have to take minus g. So, acceleration time graph is in this way you will get minus g. Acceleration time graph is minus g. The following graphs are not possible. Why, sir? If you take this graph, if you take same time, you have two displacements. At same time, you have two displacement. Here one displacement, here one displacement. That is not possible. Next, this graph is not possible. Time becomes back. That is also not possible. At same time, you have two velocities. That is also not possible. Distance time graph, this is also not possible. Why distance time graph is not possible? Distance never decreases. Distance always increases. This graph is not possible. Distance time graph, distance never negative and never decreasing. This graph is not possible. Speed is always positive. Speed never negative. Speed may decrease. Speed may decrease but never negative. This type of graph is not possible because speed is distance by time. Speed always positive. If your body is projected up, then speed time graph. Projected up means first speed decreases, uniformly decreases. But after that, speed increases, but reverse direction. But speed is, velocity here positive, here velocity negative, but speed is always positive. But speed is increasing positive. Suppose corresponding velocity time graph is drawn, that graph is velocity decreasing, here negative velocity. Velocity time graph is in this way, but speed is never negative. That's why speed time graph is in this way. VT graph is shown in figure. Velocity time graph is shown in the figure. Find the acceleration of the particle at t equal to 2 seconds and t equal to 5 seconds. So, up to 2 seconds, the slope, not only t equal to 2 seconds, t equal to 1 second also, t equal to 1.5 seconds also. So, you will get the slope. What is that slope? slope is equal to y2 minus y1, y2 minus y1 by x2 minus x1. So, this is the slope, velocity time graph. Slope is velocity time graph. Slope gives the acceleration. So, acceleration is equal to 10 meters per second square. It is seconds, it is meters. Not only at 2 seconds, here too, here, any point if you consider, slope is 10 meters, 10, so acceleration is 10 meters per second square. But at t equal to 5 seconds, not only at 5 seconds, from 2 seconds to 6 seconds, 2 seconds to 6 seconds, slope is 0. Y 0, y2 minus y2 minus y1, 20 minus 20 by x2 minus x1. Y2 minus y1, 20 minus 20. What are its coordinates, for example? Here 6, 20. Here 2, 20. Coordinates. Y2 minus y1, 0. So, at t equal to 5 seconds or t equal to 4.5 seconds, t equal to 4 seconds, t equal to 3 seconds, acceleration is equal to slope 0, slope 0, so acceleration is 0 because velocity time graph slope is acceleration. Suppose same graph, we get acceleration 0, at t equal to 2 seconds, this is 20 by 2, 20, this is 20 by 2, this is 10 meters per second square. So, acceleration at 5 seconds, acceleration is 0. Average velocity between t equal to 0 to t equal to 6 seconds. T is equal to 0 to t is equal to 6 seconds. Average velocity you have to find out. To find out this average velocity, velocity time graph, average velocity is total displacement by total time. Displacement, area under velocity time graph up to t equal to 6 seconds, area you have to find out. Area under velocity time graph. Area under velocity time graph is displacement. We already told. So, displacement is what? Half into base is 2 into height 20 plus 20 into 6 by 6. Average speed of the particle from t is equal to 0 to t equal to 14 seconds. Average speed means total distance by total time. So, this area plus this area plus this area plus this area, because distance is always positive, this area plus this area. Always speed, to find out the speed, areas you have to add this area plus this area plus this area plus this area plus this area by total time is average speed. Distance covered by the particle from t is equal to 0 to t equal to 12 seconds means 12 seconds. Distance means this area plus this area plus this area plus this area. Plus area you have to consider. Displacement if they are asking, suppose instead of distance, if they are asking displacement, this area plus this area plus this area minus this area. minus this area gives the displacement. Instead of distance, if suppose they are asking displacement. For a distance A1 plus A2 plus A3 plus A4 plus A4 you will get, but displace up to 12 seconds. But they are asking displacement A1 plus A2 plus A3 minus A4. A body starts from rest. Travels a distance s with uniform acceleration. For this one, it is better to draw the velocity time graph. For these problems, you have to draw the velocity time graphs. Body started from rest, travels a distance s with uniform acceleration. For uniform acceleration, velocity time graph is in this way. Uniform acceleration, velocity time graph is in this way. For this time, then it moves uniformly. Uniformly means velocity constant. Uniform motion means velocity is constant. That distance, this distance is s, this distance is 2s, and finally comes to rest, retardation. Velocity time graph for retardation, uniform retardation is in this way. So this distance is s, this area gives this distance, this area gives 5s, this area. This area is 2s, this area is 2s, and after further 5 seconds, distance under uniform retardation, this is 5s. First acceleration, s distance, then uniform velocity means velocity constant 2s distance, and finally comes to rest after further 5s distance. That's why I am writing the velocity time graph. This area gives displacement. So velocity time graph area is displacement. Let us take this is velocity is maximum velocity. They are asking the ratio of average velocity to maximum velocity. So this distance is equal to this area. This area is how much? Half into base is T1, height is V maximum. So V maximum into T1 is 2s. T1 is equal to 2s by V maximum. Next, second one, this time is T2. This area is what? This area is what? V, height is V maximum into T2. So T2 is equal to 2s by V maximum. Next, this area T3, let us take this time is T3, that T3 is equal to half into base, how to find out that T3? So you can write V maximum is equal to V maximum into, V max, this area is 5s, 5s is equal to half into base is T3 into V maximum. So T3 is equal to 10s by V maximum. S by V maximum. Average velocity, total displacement by total time. Total displacement by total time. Total displacement s plus 2s plus 5s. Total displacement, first s, next 2s, next 5s by total time. First 2s by V maximum, 2s by V maximum plus 10s by V maximum. Total times here we determined. First time is 2s by V maximum, next time is 2s by V maximum, third time is 10s by V maximum. So, then what you are getting now? Then average velocity is equal to 5 plus 2s, this is 3s plus 5s, 8s by 2s plus 2s, 4s plus 10s, 14s, 14s by V maximum. V maximum comes to numerator. So, average velocity by maximum velocity. If you want to find out average velocity by maximum velocity is equal to 8s by this maximum velocity comes down. 8s by 14s, that is equal to 4 by 7, 4:7. Now, between two stations, a train starts from rest. First accelerates uniformly, then moves with constant velocity, and finally retards uniformly to come to rest. If the ratio of times taken 1:8:1, the maximum speed is 60 kilometers per hour, then what is the average speed over the total journey? Between two stations, train is started from rest. First accelerates uniformly, then velocity time graph is, uniform acceleration velocity time graph is in this way. Then moves with constant velocity, velocity time graph is in this way. And finally, retards uniformly comes to rest. Let us take this time is t1, that means pura time t1, this time is t2, this time is t3. Now, this distance can be calculated. That distance is equal to half into base t1 into height. Height is how much given? 6 kilo, V maximum. V maximum. So, t1 into 60, I am writing here, S1 is equal to half into V maximum is 60, height into base t1. That t1 is given as 1. So, what you are getting that one? So, let us take that is 1t. You take 1t. t1 is 1 or 1t. 1t. Then what you are getting that? 30t. Next, this is 8t. Into this one, this S2 is 80t into 60, that is 480t. Then this S3 is equal to half into, again this is t, into 60, then that is equal to 30t. Then average speed is nothing but total displacement by total time. Total displacement is 30t plus 480t plus 30t by t plus 8t plus t. That is 540 by 10t, 50 kilometers per hour. So, I am taking this time is 1 means t. This time is 80t. This time is again 1t. This is t, this is t. We are using velocity is 60 kilometers per hour. So, S1 you can area, S2 this area, S3 this area. Average speed means total distance by total time. Here it is going in a same straight line. So distance is equal to displacement. So we can take distance time graph, same straight line, distance is equal to displacement. Total distance, total displacement by total time. Now, one more point, in calculus, we know that acceleration is equal to, calculus based problems, we will discuss this one, acceleration is equal to dv by dt. One more, acceleration is equal to dv by ds into ds by dt. So, acceleration is equal to v into ds, ds by dt is v into dv by ds. So, a ds is equal to v dv. If you integrate this one, integral of a ds is equal to, suppose initial velocity u, final velocity is v, integration v square by 2, integration limits are u to v, so v square minus u square by 2. So, a ds meaning is that, suppose if you draw acceleration displacement graph, that graph comes in this way, this is a, this is ds, this area ads integration gives this total area, integration ads is area, integration total area. The total area is nothing but v square minus u square by 2. We wrote that acceleration time graph area is change in the velocity. Acceleration displacement graph area is v square, final velocity square minus u square by 2. Based on this one, we are writing this one. The acceleration displacement ax, x means displacement graph of a particle moving in a straight line is shown in the figure. A particle starts from rest, then find the velocity of the particle when displacement of the particle is 12 meters. So, this acceleration displacement graph area is v square minus u square by 2. Acceleration displacement graph area is v square minus u square by 2. What is this area? This area, how you can calculate? Half into base. This area, if you calculate, half into base is 2 into height is 2. This area is 2. Similarly, this area is, this area if you calculate, if that area is what, you are getting that 2, 8, area is, difference is 6, 6 into 2. Similarly, if you calculate this area, you will get this area if you calculate, and this area if you calculate, this area is half into base, half into base is, this base is 2, height is 4, this one, this area. Now, this trapezium area also you can calculate, that is 6, otherwise you can take two, one triangle and one this square. Triangle area is half into 2 into 2, this area, plus this area 2 into 2. Then you will get 2 plus 4, 6. So, total area is, you can calculate 10 plus 12, 22 plus 24. So, v square minus u square is equal to 48. V square is initially starts from rest. So, u value is 0. U value is 0, V square is equal to 48, V is equal to root of 48. Root of 48 means 4 root 3 meters per second. In this way, acceleration displacement graph area gives V square minus U square by 2. Thank you.